Welcome to lesson number 4, factoring applications. So with this lesson we're going to be factoring a squared x squared minus b squared y squared, and also a of f of x squared and b squared of f of x squared. Now this is kind of a fancy way of saying our difference of squares. So if you remember our difference of squares, that is when we are going to have a binomial, so two numbers that are both going to be perfect squares, which we can factor with a positive and a negative. So then the expanded form of ax minus by times ax plus by would then be a squared x squared minus b squared y squared, because we would get rid of the middle term. They would just cancel each other out. And so then if we were to factor this, or factor this, then we're going to be left with ax minus by and ax plus by. Okay, so let's look at a few of these examples. So 9x squared minus 16y squared. Again, 9 and 16 are both perfect squares. We can factor them by finding the square root of those. So 9x squared, we're going to have 3x. 16y, I'm going to have 4y. And then since it's a difference of squares, I know that when I factor it, it'll be 3x plus 4y. So this will give me my final answer right here. Now if I look at the next question, let me just separate that. If I look at the next question, 3x cubed y minus 27x y cubed. First of all, 3 and 27 are not perfect squares, but they are both divisible by 3x y. And so I'm going to factor 3xy out. So I'm going to take 3xy outside of the brackets. Now if I take 3xy out of this first term, I'm going to be left with x squared, since 3xy times x squared would give me 3x cubed y. And then I'm going to subtract this term, negative 27x y cubed. But if I factor 3xy out of there, I'll be left with 9, which gave me 27, but also y squared. Now if I look at this term in the brackets, x squared minus 9y squared, now I have a perfect, or I have a difference of squares. So I'm going to be left with 3xy. My difference of squares is going to be x minus 3y times x plus 3y. Okay, now with this next question, I again have difference of squares. I have perfect square 144, p squared, q squared, and 4r squared. Now with this one, they're also both divisible by 4. Alright, so the reason that we would take the 4 out of the brackets first to begin with is because we're going to have to simplify at the very end anyways. And so this, if I take the 4 out of both of these, I'll be left with 4 times 36 p squared q squared minus r squared. Now I'll have a smaller difference of squares, which is good because I won't have to simplify it further. But when I take the difference of squares, I'll be left with 6 pq minus r multiplied by 6 pq plus r. Okay, and so with this unit, or with this this lesson, you are going to be working with difference of squares. And so difference of squares, that will be a little more complicated because you're working with multiple coefficients and multiple terms that are squared. All right, let's look at example number 2. A pane of glass is rectangular with an area of 49x squared minus 16y squared in feet squared. Okay, so if I have a pane of glass, then the area, okay, the space inside is going to be 49x squared minus 16y squared, and that is in square footage. Okay, so then I want to know what my length and my width are going to be. And so my length and my width are actually going to be the factors once we break this down. And so if we were to break down 49x squared minus 16y squared, right away we know that this is a perfect square. Or not a perfect square, but difference of squares. And so if we were to factor 49x squared minus 16y squared, then our factors are going to be 7x minus 4y, because I took the square root of both of those, times 7x plus 4y, which will be my length and my width. Okay, so that means that our length is equal to 7x plus 4y, and our width is equal to, oh, I got these backwards over here, so I'm just going to switch those around. And our width is equal to 7x minus 4y. And these, remember, are in feet. Okay. Now, let's look at part B. Given that the length of the pane is double the width and the perimeter is 56 feet, develop a strategy for determining the length and width of the pane. All right, so we know that our length of the pane is double the width. Okay, so if I write this out as a 7x plus 4y is going to be, so my length is actually 2 times the width. So it's going to be 2 times 7x minus 4y, since that was my width. I also know that the perimeter is 56 feet. Okay, so develop a strategy for determining the length and width of the pane. So if I know that my perimeter is 56 feet, then that means that when I add 7x plus y, or 7x plus 4y plus 7x plus 4y plus 7x minus 4y and 7x minus 4y, those are all going to equal 56. Okay, so if I were to write that as an equation, I would say 2x plus 4y, since this is my length, and there's 2, I'm multiplying by 2 because there's 2 of them in the perimeter. And then if I'm taking the perimeter, then I'm adding my width 2 times as well. So I'm going to multiply my perimeter by 7x minus 4y, and those are going to equal 56. Now what we need to do is we need to solve for x and y in both these cases in order to find out what my actual length and width are. Okay, so we're going to use this system of equations. All right, so this is corresponding to 2 times my length and width, and this one is corresponding to my actual perimeter. Okay, so if I were to solve this out, this is going to end up giving me 14x plus 8y. All right, so I just did my FOIL method. So 14x plus 8y plus 14x right here minus 8y. That should be an x, and that is equal to 56. Now if you look at, I have a positive 8y and a negative 8y, those two terms are going to cancel each other out. And so what I'm left with is 28x is equal to 56. All right, so 28x is equal to 56. If I divide both these terms by 28 in order to get 28 by itself, then I'll be able to solve for x. So 56 divided by 28, x is going to equal 2. So my equation is right over here. This is the one we figured out first, where we had my length, and that my length is equal to 2 times the width. So you have 2 times 7x minus 4y. All right, so let's bring this over here. So 7x plus 4y being my length, and I know that my length is double the width, is double, so 2 times the width, 7x minus 4y. So this is going to be the second equation we're going to use to solve our equation. Now we need to expand this equation, being 7x plus 4y is equal to 14x minus 8y. The next thing we need to do is bring everything over the other side, okay, or everything to this side. So let's do that. We'll have now, if I bring the 7x over here and the 4y over here, I'll be left with nothing on this side, so I'll have 0 on this side. So 0 will be equal to 21x, 7x, and then I'm bringing the 4y, so negative 4y, which will give me negative 12y. So 7x minus 12y will be equal to 0. And so I got this equation by, since I have 7x over here, I subtract 7x from both sides, and then I subtract 4y from both sides, which will give me 7x minus 12y. Okay? Now, I know what x is. Remember, I found out that x was equal to 2. So I'm going to go ahead and I'm going to plug x into my equation. So if I know that x is equal to 2, then that means that 7 multiplied by 2 minus 12y will give me 0 is equal to 14 minus 12y. Okay, so if I were to now solve for y, I'm going to bring this 12y into the other side. So 12y is going to equal 14. So what I did was I added 12y to both sides. Alright, so 12y is equal to 14. Now to solve for y, I'm going to divide by 12. So that'll leave me with 14 over 12, or 7 over 6 if we were to simplify that. Now the last step to do is now to plug these numbers, y and x, into our original equation. Okay, so since x is equal to 2 and y is equal to 7 over 6, we're going to plug these into our original equations for length and width. And so remember that my length was equal to 7x plus 4y in feet, and my width was equal to 7x minus 4y. So now all you need to do is plug in your x into the 2 and the 2, or plug 2 in for x and plug 7 over 6 in for y. Once you do that, you are going to get 7 times 2 plus 4 times 7 over 6. And if you type that in your calculator, you will get 18 and 2/3 in feet. And for the width, 7x, or 7 times 2 plus, or minus, 4 times 7 over 6. Plug that in your calculator, and you will get 9 1/3 feet. So 18.667 and 9.33 feet. Alright, so the method of difference of squares, in which a squared minus b squared is equal to a minus b times a plus b, can also be extended to include examples where a and b represent polynomials. So the following process can be used to factor x to the 4 minus 16y4. And so you might recall that we did this we did something like this in an earlier example, when we substituted a for x squared, and now we can do this with polynomials, and we'll substitute b for 4y squared. So the expression then will become a squared minus b squared, which will then factor into a minus b and a plus b. And so then at the end, you'll replace it with your original values. So you'll replace a by x squared and b by 4y squared to get x squared minus 4y squared and s squared plus 4y squared. And then from here, you can factor even further, because then this will be a difference of squares, which will give you this final answer. And then this one, since it's not a difference of squares because you have a positive, you will not be able to further simplify this. Okay, so let's look at our examples. If I have k to the 4 minus 1, I'm going to say that, okay, if I have k to the 4, this is going to be equal to k squared minus 1 squared. Okay, so if I have k squared, then this is going to simplify into k squared minus 1 and k squared plus 1. Now, notice that if I have k squared minus 1, that is a difference of squares, right? And so if I have a difference of squares represented, then I know that that's going to be k minus 1, k plus 1. But since k squared plus 1 can't be simplified any further, that's just going to be k squared plus 1. Okay, so we're going to continue using our difference of square methods. If I have 80a to the 4th minus 5x to the 4th, neither of these are perfect squares. Neither of these numbers are perfect squares, so I'm going to factor these numbers first to make them perfect squares. Now, they're both divisible by 5, so I'm going to pull 5 out of there. Okay, so that's going to equal, so 5 times 16 is 80. So 16a to the 4th minus x to the 4th. Okay, so now we have perfect squares we can work with. Now, if I have 16a to the 4th, just like we did in this example up here, this can become, we can treat this as 4a squared squared. Okay? So 4a squared squared, because if I take the square of 4, that'll be 16, and the square of a squared will be a to the 4th. Likewise, for the x to the 4, I'm going to make that x squared squared. Okay, now the reason we do that is we can then have two difference of squares kind of happening here. Okay, so with this first one, if I were to treat this as 4a squared as a squared and x squared as b, so a and b, then what I could have is another perfect difference of squares. So that would leave me with 4a squared minus x squared times 4a squared plus x squared. Okay? Now, from here, I again have my difference of squares that I'll be able to work out. And if I have 4a squared, that'll be left with 2a. X squared will be x. And then since this is a difference of squares, I'll be 2a plus x. And I'll multiply that by 4a squared plus x squared. Okay, and that's my final answer right here, that big long answer there. Now let's look at this last example. So 2p to the 5th times q to the 4 minus 162 pt to the 4th. Now the first thing I'm going to do is I'm going to get rid of this 2 here. And actually, I could get rid of 2p since they're both divisible by 2p. So if I take 2p out of here, I'll have 2p on my outside. And then I'll have, if I take 2p off, p to the 4th. And then I'll have q to the 4th minus 162 divided by 2 is 81. And if I take 2p out of there, that's just going to be 81 to the 4th. 81t to the 4th. So the next thing I'm going to do is, just like I did last time, if I have p4 to q4, I could treat that as pq squared, q squared to the square minus 81 squared is going to be 9t squared squared. Okay, so again, I already have a difference of squares. If I treat these middle terms as a and b, which would give me 2p times p squared q squared minus, oh, I don't want this bracket there yet. Hold on, I'm just going to grab a little bit of white out. Sorry about that. A little too quick with that bracket. So I have p squared q squared minus 9t squared times p squared q squared plus 9t squared. All right, and so if I look at this p squared q squared and this negative 9t squared, I can factor this down further into a difference of squared. And so then I'll end up just like this question over here with 3 terms. Okay, so that'll be pq minus 3t times pq plus 3t times p squared q squared plus 9t squared. And that is my final answer. Okay, so again, I have difference of squares here. Now, it's easiest if we think of these difference of squares as, well, first of all, a is its own term, and b minus c, this is its own term, okay, so it's in brackets. And if you want, you could start by saying that, we could say that capital B is equal to b minus c, okay? So anytime we see b minus c, we're gonna think about this as a squared minus b squared. Okay, so if we have a squared minus b squared, then we know if that's going to be a difference of squares. That's going to be a minus b times a plus b. But we know that that's capital B, by the way. But we know that these capital B's actually mean b minus c. So we're going to reinsert a minus b minus c times a plus b minus c. Okay, so then what we're left with is, if I get rid of these brackets now, is a minus b, a negative and a negative are going to be positive. A minus b plus c times a plus b, positive and negative, it's a negative, minus c. All right, now this last one. Again, we're going to approach this the same way, okay? So I'm going to say instead that 2x minus 1, 2x minus y is equal to a, and x plus y is equal to b. All right, so now it's going to be a squared minus b squared, and I know that if I have a difference of squares, that's going to be a minus b times a plus b. Remember that a and b aren't actually a and b. Okay, so I'm going to reinsert what that actually means. So that means that 2x minus y minus x plus y times 2x minus y plus x plus y. All right, and so we're not out of the clear yet because we need to simplify this. Now, if I get rid of these brackets, that's going to become 2x minus y minus x minus y. This negative will make this into a negative. Okay, and then we're going to multiply that by, if I get rid of these brackets, 2x minus y plus x plus y. And we can simplify that even further by adding together my like terms. All right, so I have a negative, and I have 2x and a negative x. So then I'll be left with x minus 2y. And let's see what I have here. I have 2x plus x is 3x, and then y, and it's just 3x. And so I'm left with x minus 2y times 3x. And if you want, you can rewrite it like this: 3x times x minus 2y. Okay, let's look at this final question. Factor the expression 36 times x plus 5 squared minus 49 times x minus 8 squared. Okay, so the first thing we're going to do Alright, so this last question is again a difference of squares. Now, it's easiest again if we think of these terms here as just, simple coefficients. So I'm going to say that let's let x plus 5 equal a, and I'm going to let x minus 8 equal b. Okay, so now what we have here is 36a squared minus 49b squared. All right, and so if I were to take the difference of squares with 36a squared and 49b squared, what I'm going to be left with is 6a minus 7b times 6a plus 7b. Right? I can't leave it like this though. If I leave it like this, it won't be correct. And so now remember that a was equal to x plus 5. Now I have to put that back into my equation. So that's actually 6 times x plus 5 minus 7 times x minus 8. And we're going to multiply that by 6 times x plus 5 plus 7 times x minus 8. Okay, so if we expand that, I had an extra bracket in there. That's going to be 6x plus 30 minus 7x plus 56. And then on this side we'll have 6x plus 30 plus 7x minus 56. Okay, now from here we need to add our like terms. And so I have a 6x and I have a negative 7x there, which will give me negative x. Then I have a positive 30 and a positive 56. That'll give me 86 minus x. And then on this side, I have a 6x and a 7x, which give me 13x. Then I have positive 30 minus 50, which would be negative 26. Now, you're almost done, but not quite, because 13 and 26 are both divisible by 13. Okay, so I can break this part of my term down even further. So let's go up here. Okay, so I can break that term down even further. 13, so let's move it over here. So 86 minus x. If I take 13 out of this equation, now 13 will be outside of the brackets. 13 out of 13x is just going to leave me with x. 13 out of 26 will be x minus 2. All right, and now we can rearrange this. If 13's outside the brackets, I'm going to leave it like this: 13 times 86 minus x times x minus 2. And that's our final answer.